So this one's really nice. When I do the derivative, it's just a beautiful, simple thing. And then that's beautiful. Yeah, there's double prime.
Oh, you can do that, but
Right? 15 comes out, x squared comes out. And then this is just the difference of squares.
because it's
So sure enough, I did that.
yeah, you just take the before you factor and then factor. Or no, factor.
Just a little test strategy. If I give you a function and you're like, oh my god, I don't know if I can do that derivative. You already know that you can kind of do these and then you can come back to that later. Does that make sense? You already know that you're supposed to be, so you can totally do all this shit. And then, if you have time, you can come back and try to do that derivative, right? It's just get done what you know you can do, and then come back and do what was weird, if you want. So what are the critical numbers? These are all beautiful.
1,
1,
Zero.
negative 1, 0, 1.
I like it. Yes?
Wouldn't 0 be a double root?
Yeah, totally. So now the multiplicity can come in, right? But for right now, it is definitely a critical number.
But since the derivative doesn't matter, right? But if it was like regular...
No, it totally does. So I'm going to use multiplicity in my explanation for the sign diagram. Since 0 came from a term with multiplicity 2, both sides of it should have the same sign. It shouldn't change signs. So what I can do then, negative 1, 0, 1, 0 in each of those places. If I put like a 5 in, that's definitely up here, right? But let's just put a 2 in. If I put a 2 in, positive, negative, positive. So it's negative. 1 came from multiplicity odd, right? Multiplicity 1. So it's going to change signs. 0 came from degree 2, multiplicity 2. Signs stay the same. Negative 1 came from multiplicity 1 odd. It's going to change signs. Done. Yay! Quick.
Wait.
Yes.
Wait. So 0 is is a 0? That makes sense.
Totally. Yeah. If I make x 0, there's an x squared. It makes the whole thing 0, right?
So it's not undefined. So 0 is not undefined.
The x is not on the bottom. So if it was 15 over x squared, then 0 would be a critical number because it makes it undefined. But this is still a polynomial, right? And a polynomial can't, by definition, can't be undefined anywhere. Okay. Yes?
So then you're plugging these critical numbers back to the original equation, right?
What do you mean? Sorry. To get this?
Yeah, or are you plugging them back into the...
What is this sign diagram supposed to show me? What are these pluses supposed to mean where it's increasing, right?
Yeah.
And which thing tells me the f prime, 11. That is beautiful because I told you, you've got to really keep it clear what's what, and then you got to figure out where do I put this at this moment, right? If you're trying to find points to graph, f. That's its purpose. F's purpose is to tell you where the function is. You want to know where it's increasing and decreasing? F prime. If you want to know concavity, F double prime. Now, I think what I want to make sure, Wes, why was 0 undefined over here? Why did 0 make this f prime undefined?
Because of negative 1 half.
Yes, this is on the bottom, isn't it? It would be 1 over x to the 1/2, right? That's what would make it undefined. Good. Okay. So where is it increasing? What intervals?
Negative 1, 1.
Be careful. You can't just say negative 1 to 1 because what's it doing at 0?
Oh, 0.
It's flat at 0. So you got to break it up. Negative 1 to 0, 0 to 1. And of course, decreasing everywhere I haven't said yet. Is that cool? And again, you can just read that right off of this. This thing makes it almost too easy to believe. And you don't have to, but again, if I make a little quick rough sketch, down, flat, up, flat, down. And again, you don't have to, but this is really nice to do right now because then when you have to graph it, you kind of already know the shape. You just kind of capture all the important points. What are the, how many minimums are there?
One.
There's one min, and it's at what point?
Negative 4.
-1 comma,
Negative 2.
-2. I love, just plug a -1 now. Now, again, I'm trying to figure out a point that my function goes through. I have to use f. Right? I mean, if I plug -1 into the derivative, I'm going to get 0. That doesn't really tell me shit. I need to know where the function is, correct? What about the max?
1, 2.
1, 2, kick ass. Again, I know it's at 1. Just plug a 1 into the function, get 2. Okay. So far, really nice points. I should have made this have some funky ass huge outputs, but too bad. Too bad for everybody. So this is, do you see how I definitely don't want to start doing a derivative with this version? Wouldn't this be a triple product rule? If you want to.
Wait,
That's what I
Yes.
a little bit right.
And real quick, if you really don't want to do this, can you still tell where there's a minimum? Isn't there a minimum where it's going down and then going up? So I can tell there's a minimum here even without this picture. And then there's a maximum where it's going up and then coming down. So that would be a maximum, right? So I don't have to draw that little sketch. Okay, maybe. You guys okay? Good? Okay, all right. So where do I want to start to figure this guy out? What do I want to start with?
I want to put the original. So.
Yeah, what's the original f prime? Isn't it this dude? Doesn't that look so much better than this freaking dude? Now, would you get the same answer? Yes. If you use this, is it easier to make mistakes? Oh shit, yeah. All right. So what do I get when I take this guy through? Nice and easy.
30x
30x?
minus 60x times
60x.
cube.
I love it. And then you just factor this. Oh, let me make double one there. Factor this.
30x.
And then, I mean, this is where you can just get away with just copying what I got, right? Now, to be really honest, I could factor this one more step, believe it or not. Right? And that sort of tells me all the multiplicities will be 1. Because I could break this up and they would both be x to the first power, wouldn't they? Well, you don't have to. So what are the critical numbers? Let's see. I'll do this one. Yay, okay.
Plus or minus square root of 1.
Yeah, you just take this, set it equal to 0, right? So 1 equals 2x squared, divide by 2, take a square root, you get plus or minus square root of 1 over 2, which is plus or minus square root of 2 over 2.
That right?
That feels very trigonometric, right? Maybe? Okay. So I get 0 and plus or minus square root of 2 over 2. Let me stop. So I mean, as long as you remember your plus and minus, it's perfectly fine to solve it that way. Yeah.
How come professors always like to put the root at the top after getting like ratio inside of it?
It's not just professors, we generally, okay, so fraction sucks already on its own a little bit compared to 7, 3 over 11 sucks, yes? Radicals on the bottom make them suck even worse. So in general, it's just convention to not say 1 over square root of 2, which is what that would be, because now I'm dividing by freaking irrational. Division is bad enough already. So square root of 2 over 2. In fact, do you guys know square root of 2 what it is roughly? Do you guys know that? Anybody? It's 1.414. So stay with me. So if I wanted to approximate, square root of 2 over 2, it's easy now. 1.4 divided by 2.7. It's roughly 0.7. Yes? If I want to approximate 1 divided by the square root of 2, screw that shit. Yes? Because that would be 1 divided by 1.414. Have fun with that. Does that sort of make sense? So it's just convention. We just were like,
Makes it easier.
yeah. Okay. So again, do you see how that's a first power, right? And if I were to factor this, now watch this. Square root of 1 is 1, square root of 1 is 1, minus, plus. Square root of 2 is square root of 2, square root of x, square root of x. Square root of 2 is square root of 2. That's any difference of squares. As easy as shit. You screwed everything, put minus and plus in the middle, and you're done. The only reason I'm doing this is because now I know the multiplicity of every freaking thing is odd. Which means what's going to happen to the signs in my sign diagram? They're always going to change. So I only have to do one stupid number in, and I just change it everywhere. Does that? So multiplicity is a remarkably good thing to know. So I got my negative rad 2 over 2, 0. So if I put 10 in, isn't 10 up here?
Right up there.
Yeah. So if I put 10 in, I'll get positive times 1 minus 200 is negative. So I get positive, and it's negative up here. Which means what is it? Let me put my little zeros in there. What is it here? Positive. Negative. Positive. Oh my God, that saves so much freaking time. Maybe I'll convert some of you guys. Or if you don't want to remember, you got to remember so much from multiplicity. Odd means changes, even means doesn't change. It's a lot to remember. So if you'd rather just plug numbers from every region, feel free. What number would you use between 0 and square root of 2 over 2? Yes. Yeah, you're really close to 0, and then plug in your calculator, right? But you're wasting time then. Yeah? Maybe? I don't know. Okay. So where is this concave? And what can I draw underneath if I want to? What does this mean? Up. Down. Up. Down. Left, right, A, B star. So then, where is it concave up?
Negative 15.
Okay, or?
0.
0 rad 2. I mean, this is easy now, right? Up is where it's positive. All I said, there it is, I can see it. Down would be negative rad 2 over 2 to 0, union with rad 2. Good Lord, Jeff, what is that? Infinity, right? So, what are the points, inflection points?
0 or plus or minus 0.
Yeah, so there's going to be inflection point there. Every single critical point just happened to be inflection points. There's an inflection point at, now this is where I need your help. Negative rad 2 over 2, comma, what? Where am I going to put that to figure out the output?
In the second.
The original function, because now I want to know where the hell that function actually is, right? So can somebody do that? Negative 1.237. 1.237. Okay, I got one possibility. Did anybody verify that? Not that I don't mistrust Amy, but it's always good to get verification. I'm going to try to do it by hand. All right. No? Yes? Maybe? No?
Working on it.
Poor Chloe. She's the only one trying.
Yeah, it's good.
Yeah? Okay. And then there's one at rad 2 over 2, right? So when you plug that in, it's just going to be positive. It should be. And then there's one at 0. 0. Kick ass. So that's important to know. This is important to know. Okay.
So you plug them into the second derivative?
No. Hell no.
For the very first?
So these represent points on the graph.
Okay, so
And that is, of course, this guy's job.
Okay.
F tells you points, F prime tells you increasing, decreasing, F double prime tells you concavity. Yeah. Trust me, I know. It's like shifting gears when you're first learning how to drive a stick. plug it back in the appropriate place at the right time, and that's easier said than done sometimes. But you gotta remind yourself right then, am I trying to get a point that exists on the thing, or am I trying to do something else? Yes?
So which equation are you plugging the negative square root 2 of 2 to?
Right here.
Yeah, for IP.
So again, that IP is a point on the graph. F, F prime, F double prime, which one tells me points on the graph?
On the graph?
Yep.
Be the first derivative, right? Or first derivative?
No, that tells me slopes.
This will be second.
So it's the
Second.
original dude, isn't it?
Yes, wait, the original, yes.
Yeah, how do I figure out a point this goes through when I just plug an x value into F? So anytime you're actually trying to find points, right? Points, you have to use F. Okay, I like it. Now, watch this. This is kind of interesting. Again, I'm sorry, I really should have made these outputs grosser, because then we could have talked more about scale. But again, every single important point is 1, 2, right? So to be honest, let me see if you guys are cool with this. Let me see, this is really good. So, the output for my maxes and mins are like -2 and 2. The output for my inflection points is -1.2 and 1.2, right? Right? Do you want to go up to 5? You have control over the frickin' scale. You have complete control over the scale. So we're all used to like making it 10 or 20 if I get big ass numbers. But if you get small ass numbers, you can give yourself more room. So let me not go 1, 2, 3. Let me go 0.51, maybe? Let's make this 0.51, 1.52, 2.5, yeah? And then even here, what do my inputs look like that are for my important points? What are my important points? These guys, and the inputs are -1, 1. These guys. And remember, what was rad 2 over 2? That's like 0.7, right? So I want more room there too. I really want this to make sense right now because the scale is more important than people think. So I'm going to make this one 0.5 also. Why not? Give myself more freaking room. Yes? Let's check. You can do it then. There you go, buddy. You guys understand that? You got to realize exactly what it is you have control over. Because you don't have control over a lot, do you? You can't suddenly go, no, I want inflection point to mean this other thing. No, you can't do that shit. But here, you have complete control. Right? You have to embrace that. Okay, okay. So let's start. Let's do this. What are my intercepts? Oh, this could be words of problems, yeah? Damn it. I love myself so much. Let's see, I think this might be a problem. How do I find my intercepts? My y-intercept?
Make it 0,
Yeah, this will be nice, right?
0, 0.
Let x equals 0, so I get y equals 0, yes? Maybe this won't be too bad. No, this will be fine, Jeff. Okay, you're fine. Now, x-intercept's going to be more interesting. But y equals 0, so 0 equals 5x cubed minus 3x to the 5th. How do I solve that? Good, factor out an x cubed. So this is just going to be the 0 that I already knew, right? I already knew that point. What does this give me? So 5 equals 3x squared, right? 5 by 3, take the square root, I get plus or minus square root of 5 over 3, which you could rationalize. Okay. I feel a little better. I was concerned. I was concerned for a moment because I made my scale before I finished finding all my points. And what if the y-intercept would have been 0, 360? My scale would have obviously suffered. Yeah? So I got a little lucky there. Okay. Now, we're doing this by hand, correct? So screw frickin' square root of 5 over 3. What is that shit? Somebody help me out. What is that?
1.291.
Alright. So I got 1.2910 and negative 1.2910. That's my x-intercepts, yes? And then I got 0, 0. Now let's do this. Min and max. Thank you, min and max. You kick ass. Are my inflection points here nice?
No.
Are they? No. So let me rewrite them. And I already kind of gave this to you. Rad 2 over 2 is basically 0.7, right? So it'll be negative 0.7, negative 1237, and positive 0.7, 1237, and 0, 0. So there's my inflection points. So in this case, since we're doing this by hand, obviously rad 2 over 2 doesn't do shit for me. Where is that on the number line? Go ahead and make it a decimal. 1 decimal place is fine. You can't be more precise than that. So let's plot some shit. 0, 0. Yay. You gotta love your anchor points. And then 1.291. Okay, you can be a little good about this. Isn't that 1.25 right in the middle? See how this is so much nicer of a scale? 1.2910. So it's going to be about right there. And negative 1.2910. Right there. Okay, let me stop for a minute. Are you guys? So it's really unfortunate pre-calculus is where they should really, really make you really do scales and just get used to making a good scale. And this is the one that I don't think you get enough practice with, is blowing it up, making the scale by a half or a quarter. What else can we plot? Let's see. What's our minimum? Negative 1, negative 2. And we're like, thank you very much again for being such a nice point. And I'm going to label that as min. So that when I come to it, I know I'm going to turn. Yes? My maximum is 1, 2. Then remarkably enough, I'm going to label that. And I'm kind of being smart about it. I label the min under it and the max over it, so it's not on top of where I'm going to graph. Are you guys kind of following? So I'm trying to be nice to myself. Tell myself what the shit's happening at each place. Now let's do the yips, the IP. Negative 0.7 is about right here. Negative 1.237 is about right there. So there's an inflection point there. And then positive 0.7 is about right there. And then positive 1.237 is about right there. Okay. So still, I could have even probably made it even more zoomed in. Oh, that's fine. All right, here we go. So where do I start? Here's my picture of my shape, right? So I start, and if you didn't draw this, you just know it's going down, right? So I'm going to come down through my x-intercept here. Then I'm going to hit the minimum. Now, what's the concavity start off as? Concave up. Right here, right? Concavity. Concave up. So I'm kind of trying to make this concave up a little bit. What happens right there? Switches to concave down. So now I want to kind of focus on doing this shape. You see what I'm saying? IP right there. I love that sense. Inflection point right there. So as I come on this side, I'm going to focus on making a cup up shape. And now I go, okay, now I'm going to focus on making cup down, right? So now you're going to go, and I'm still going to go through there. Jesus, Jeff. I didn't do that very well. All right, let me try again. Go through there. Oh, I could have probably zoomed out a little more. This really is not a lot of room. All right. There we go. And then right here, I'm going to change to. Did I miss 0? I totally missed 0. That's what happened. I love myself. What did I not label? This is kind of nice that I made a mistake. What did I not label?
So it's 0,
0,
0.
0 is one of my IPs, right? Damn it, Jeff. Alright, so let me see if I can salvage this.
What are you doing
Do you
with
need
Oh,
Play-Doh?
okay.
I didn't
Yeah.
label this, so I didn't know when I hit it that I was supposed to change. Does that make sense?
that? Yeah.
So I should be going down, and then after this,
Go for
I
it.
should be going up. Now that makes more sense, yes? Because then I can hit that. And then this is an inflection point, so now I'm thinking cut down through this. This one kind of sucks because it's so jammed in here. That really sucks because of the mistake I made. I love it. But now you see how important it is to make sure you label everything. And my mistake was I plotted 0, 0 as an x-intercept, but then I forgot that it was also an inflection point. Yeah.
So what exactly did you do graphically at the inflection points?
All right, so I know it starts concave up. So through this region, I'm trying to capture this, right? The minute I hit this, now my thought process goes, after this, I want to capture this. So I come out of this with a curve down.
Okay, even though it never comes really down, it's still concave.
Yeah, it's concave down because the slope is decreasing as I go up.
Okay.
So if I kind of follow what this is doing, it would do this, right?
Yeah.
Now, but at this point, now my brain is, I want to go from that point to that point, but as I do, I want to have a cup up idea, right? So cup up, another IP. Now forever after that, I want to have this cup down. Now, of course, how many of these have we done? 2, right? I love it. So of course, it takes some practice to get used to this. I have colleagues who teach this where you've got to keep track, you have to keep going back to your work. But to me, if you just, no, this is a really good thing, I made a mistake there. I didn't label it, that's what screwed me up. So if you label each important point as you're coming to it, it tells you what to do. Yes? Okay, maybe. This takes a little getting used to, but well, it takes a lot of getting used to. So what we actually just did, I don't know if you guys noticed this. Right, there are a couple other things in 4 or 5. There's reminders about asymptotes from pre-calculus and all that kind of stuff. Oh God. Oh God. Okay. In fact, let me say this. This is beautiful. It's gonna go right into there's no time. Damn you, time. You're all like, oh, thank God. I understand. Let me do one thing at least. I guess we're not going to get to... No, I am going to do it right now. Okay. 4 points. Can somebody remind me from pre-calculus, well, how do I want to say this? Well, all right. I'll tell you this. Let's do this right now. 4, 5. Can somebody remind me what this limit is?
1/2.
Yeah, why?
Just 4 very
The
much.
asymptote is 1/2.
Say again?
The asymptote is 1/2.
How do you tell?
It's
Because
4.
they have the same power.
Yeah, same degree, just the ratio of these. Because essentially, real quick, the kind of hand-wavy way to do this is when x gets really big, how important are these compared to this?
Not really.
If x is 18 trillion, that's big, but that's stupid big. So when x gets really big, which is what I want to let it do, all that shit means nothing. And doesn't that just become 1/2? So when x gets really big, this is fundamentally 1/2. That is where the horizontal asymptote would be. At 1/2. I like it. What about this guy? Yes. Which one's growing faster, the top or the bottom? If the bottom's going faster than the top, the whole thing is getting smaller because I'm dividing by bigger, 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 so of course it's going to go to 0. So then I'm going to have a horizontal asymptote on the x-axis. I like it. And of course the only other possibility would be, this is everybody's favorite.
Horizontal asymptote.
Top's growing faster, so the whole thing's going to go to infinity, right? But it's going to go in a certain way.
Diagonally, right?
Slant at diagonals, either oblique asymptote or a slant asymptote. Right? You guys remember how to find it? Then you have to do long division. Chicken ass. Chicken
That's
ass.
the same as synthetic, right?
No. Why doesn't synthetic work here? Because the bottom is not linear with slope 1. That's the only time that synthetic directly works. Right? So I could factor the bottom and apply synthetic twice. The way that I wrote it, unless I do this. All right, so we still have to do 4-4, which kind of sucks, but I wanted to do it. Well, let me kind of give you an idea. So if I have the limit as x goes to a of two functions, and let's say that it's in the form 0 over 0, right? What that means is, whatever f is, has to go to 0 at a, right? Whatever it's doing. And whatever g is, has to be going to 0 at a, right? Whatever it's doing. Yeah, so this is g, this is f. Are you guys with me? So what's interesting is, if f and g are continuous and differentiable, right? Around a. Let me say around a. So it doesn't matter if you get all freaky elsewhere. All I care about is around a. Then, isn't it true that we can write this as a linear approximation? Remember that? Oops. Remember that? Stay with me. No?
C?
This is section 310. Which is going to be on the next quiz. This is A, sorry. So I find the tangent line, and doesn't, because I mean, really, if I zoom in, doesn't this look like a straight line? Both of them, yes? Okay, so that means, and all this shit, whatever, if I knew the numbers, could I distribute this, and couldn't I just put it in this form here? Right? So this would become the limit as x goes to a of mx plus b over nx plus c. Because this would be a different, what do you want to call it? Thing. Yeah, so it basically becomes the ratio of the slopes. So I mean, I'm going to do a more in-depth proof of this, but I just want to lay some groundwork. This limit here, if it's indeterminate, becomes this limit here. The limit of the ratio of two functions, if this is true and it's indeterminate, becomes the limit of the derivatives of the functions. Now what good does that do? Well, remember this guy? Remember there was 1? Is it indeterminate?
Yeah.
Yes, 0 over 0, right? If it's indeterminate, I can apply L'Hopital's. That's what this is L'Hopital's rule. Which means this is the same thing as, what's the derivative of sine? What's the derivative of x?
1.
1. What's the limit as x goes to 0 cosine x? 1. Dude! So much easier, right? Okay, so I just want to lay some groundwork. And that's what some tutors have told you to do, but we didn't know it until 4-4. you're not all at ease until after 4-4. So we'll get more into that next time. I'll be a little more formal about the proof. That's enough for today. So don't forget that quiz Monday. I'll see you then. Yep.
I can't be here Monday. I've been going to. I tried to reschedule for
Oh, so, okay. Anytime you miss class, you can watch the video. Anytime you miss a quiz, the grade on the next test takes the place of that quiz. So basically, your test is going to count a little more to cover for the missing quiz.
It's gonna say can I be during office hours to make it out.
Nope.
See you later.
Okay. See you. Take care.
Do you have any plans for the weekend?
Oh, this weekend? Yeah. I'm gonna go kayaking, hopefully, up on Lake San Marcos. I'm trying to. I used to have a kayak, and the poor dude. It's a sad story, but basically, it got destroyed.